this is the introduction. Additionally, I do some pro bono work for a non-profit organization. So this is innovation in healthcare in Germany. And I did some consulting for the German government, but this is not the opinion of the German government if it should be. So let's go in to the middle of the battlefield at the moment. So we all have heard in the last month that there is an enormous demand for energy in the data center area. And if you look into it, so there was an article from Bloomberg, Sam Altman's New Deal, so he means a new nuclear deal, is good for AI, but what about Americans? So this is a good question, effectively. And the article effectively is based on the information on the Electric Power Research Institute in the US, but most of this also applies to Europe. What we have seen so far is that you have a high demand of 5 gigawatts per hyperscaler. So this means roughly 8 to 10 power station blocks of the current power plants. If you see this unit 1 terawatt hour per year, this is effectively to equivalent 1/7 gigawatt. So if you talk about these numbers, just compare it, and it's not as complicated. What we see is this demand. I started 5 years ago talking about the energy consumption of data centers, so this was before 2020, and it looked pretty relaxed. So this was almost constant, slowly growing, but without this enormous increase which is predicted now. You see in these predictions several scenarios. The red one effectively is an increase by 400% until 2030. 2030 is nearly 5 to 6 years from now, so it's more or less now if you have to plan a data center or if you have to plan a power plant. And effectively, if you want to build this thing with nuclear power plants, there are these new small modular reactors which have about 300 megawatts. This means for the US only, you have to build 150 small modular reactors. What do you think, how many have been built in the US so far? 0, exactly 0. And there have been built 3 worldwide, all in Russia or China. So this is a complete new design, and effectively, if you have anything to do with hardware, and especially with big hardware and on a plant scale, this means this entire scenario is completely unrealistic. This is very far from being real, and this is, I consider this a little bit as a scam of the reactor industry to get this business attached to AI. And they have have all kinds of problems. There is a YouTube video. Small reactors have a big problem. It's 7 minutes. You can look it up there. There are all the details why the planning is not really reliable and why the sizing is a big problem for them. Why are they doing this? Because effectively, the US power grid is not able to transport this amount of energy. You cannot build it somewhere and then transport it by power lines. It's just the idea that you have to attach it to your data center. So these reactors would run very close to your data center. And in this Bloomberg article you read, yeah, we have to do it because otherwise China will lead in 2030. So this is a lot of fear of missing out, FOMO. We need to retain US leadership in AI. Yeah. Okay, and effectively, this is a linchpin of our economy. And then they frame it as an AI New Deal. New Deal, this was in the 30s, to get a lot of jobs out. Effectively, what also is in the article, this is not a good business for the local subsidies. So in Illinois, they only created 339 jobs, which is effectively 1.4 million per job, and the costs for the energy has been passed on to the residents. So this means the local residents pay more, 2.5 to 3% per year for the energy. So this is a bad business if you live close to the data centers. In the US, and it's the same in Europe, data centers are extremely unequally distributed. So most of them are around Chicago or in Texas or Virginia. And if you look into the power grid, I had a customer in the European transmission grid. This is extremely hard to change because building transmission grid lines takes even longer than great power plants. If we would accept this scenario and just apply it to Ireland, Ireland at the moment is unique in Europe because it already uses 20% of the electric consumption for data centers, then Ireland would definitely have to provide 100% of the energy to their data centers. So this is not real. The links are in the article, so you can, in the slides, so you can look it up on your own. What, on the other side, there is one technology, I call it remote nuclear fusion. We have successfully established a fusion reactor in the solar system, and it's far enough away that it is not dangerous until you go out in the sun in summer and get sunburned. And the price for photovoltaic energy is shrinking exponentially. So this is an exponential scale. On the left side, so you see from 1980 to our time, it's more or less very similar to Moore's law. It's getting cheaper and cheaper every day. And the only thing missing is battery capacity, and the same, we see more or less the same with battery capacity. This is an Oxford article, it's 2 years old, so it's very old, in one of the oldest articles in this presentation. So we could have invested all this money for nuclear power plants in solar energy and batteries and would get a faster and better result, period. There is no doubt about this, but effectively all the brilliant leaders of our huge companies decided to go the nuclear way. And if we look into typical data centers, we see these pictures. Nearly half of it is used for servers, but nearly the same amount is used for cooling and power provision. There's a little bit for storage and network, but it does not really count. This did not change until AI arrived. So in the last 10 years, it was more or less the same. What we see is we have to do cooling somehow. This can be done by water evaporation, immersion cooling, or adiabatic cooling. And it counts, and there is some kind of power usage effectiveness, so this PUE value, and everybody is lying about this. So Google is presenting a PUE value of 1.9, and they even claim that they have 1.6, but they forgot the transformers. And effectively, you only can read these diagrams if you know the kind of cooling. So this must be evaporation cooling, and this means they are consuming a lot of water. And what we see in the moment, some of the data centers are definitely in areas where there is a shortage of water. Salt Lake City, even the region of Frankfurt is very dry, so you cannot run data centers with evaporation cooling if you don't have enough water. The definition of the PUE is on the bottom of the slide, so let's go deeper. What you need to do is this kind of recycling the water, and this means you have this immersion cooling, and you have to exchange the heat and the water again, that you can keep the water inside the data center. This immediately rises the PUE, this is simple physics, to nearly 1.3. So you have 30% more energy for cooling than just with water evaporation. And it's getting even worse if you need water cooling for machine learning, then it goes up to 1.6 nearly. And there are some thumb rules, so if you read a PUE value of 1.03, then they have ignored the transformers. If it's adiabatic cooling or immersion cooling, 1.34, then transformers have included this realistic value. Water cooling, 1.58 is for AI workloads, and if you have a partial PUE for transformers, only 6% is a realistic value. So here we have the comparison of two very well-established intelligence units. This is an NVIDIA Hopper. I don't know who has ever touched an NVIDIA Hopper. No, not me. Because it is size of a hand, it has a price of 30-something thousand euro, and it consumes 700 watts. If you compare it to the legacy model you all have in your head, this model uses 20 watts. And you can measure that. And you don't need only a single NVIDIA graphics card. You need lots of them for a rack, and then you raise the number of energy produced in a rack from 3 to 6 kilowatt, like in the old times, to about 30 or even 100 kilowatts. And if you are looking, what are we doing with NVIDIA graphic cards? It's the most stupid usage of graphic cards that we simulate neurons with it. So effectively, these are not neurons, these are perceptrons. If you compare it with your brain, then you see this is a neuron. This is on the right side, this is a biological neuron. It has an axon, and it is the axons are finishing in synaptic terminals. And the synaptic terminal is the closest thing you can compare to a perceptron. So if you read the numbers of neurons in the brain, this is not the value you have to compare with your neural network. You have to count the synaptic apparatus, and then it looks like this. If you have an axon, for example, every nerve has a lot of axons, then it already is effectively a two-layer neural network. So the order of magnitude of comparison must be aligned with a biological reality. And not to say all these synaptic endpoints are also a little bit computing units. So you have a chemical and electrical potential, and it can store information, and a little bit it has some computing intelligence. So it's even more intelligent than the standard perceptron. If we compare it to the NVIDIA Tensor Core datasheet, then we see the H100 has, however, 180 billion transistors, and the new Blackwell B200 will have 208 billion transistors. So this is American billion, although in Europe, Milliarde. And if you compare to the synapses in your brain, then you see you have 10 to the power of 12 synapses in your brain. And compare it with NVIDIA graphic card, then you see you need for the same number of synaptic power in your brain, you need around about 10,000 H100. This adds up or 4,000 Blackwell if they could deliver it. And this adds up to a power of at least some, if you add cooling and networking, some 140 megawatts, maybe 50 megawatt in Blackwell. So this is the amount, if you see somebody comparing, yes, we need general artificial intelligence, and it will outperform our brain, then you have to compare it, yes, but it will also outperform in the power consumption. And to make it worse, most of these NVIDIA Hopper and future the B200, the Blackwell graphic cards will run in Kubernetes, and the average power usage in Kubernetes, this was an outcome of the last KubeCon, is 20%. So most of the time, they are not really used. And yeah, one graphic card does not come alone. Normally, you put it in racks, and then you have really a rack full of these power cards, and then you need cooling. On the right side, this is a Rittal megawatt cooling device, so it can cool 1 megawatt. These are 2 Ferraris, full speed, without interruption. It's a nice steampunk device, but effectively you have to plan your data center for that. Or if you use other GPUs, something similar. Another thing, if you train your own AI, everybody at every university at the moment is complaining. It is the access to this computing power is the gatekeeper. For a simple academic research project, you need 1.2 million euro. And if you start building a data center, a small one is about 300 million euro. Planning takes several years. In Berlin, we have at the moment planning for 700 megawatts in different certain data centers. So this is will have some impact on the power grid in Berlin, and same in every power grid where it is placed. What you see in the US, especially in Texas, that coal and gas power plants are not closed. They are simply feeding the energy need. And this means if we don't do the same in German, goodbye sovereignty, we are dependent on these kind of data centers. But this is more or less a minor problem. Okay, not too pessimistic, there are alternatives already. So neuromorphic computing can also replace AI graphic card networks, but they have not been fully implemented. This is one alternative. They are spiking. They probably behave completely different than a graphics card, but you have more or less a chance without consuming so much energy, probably 1% or something like this, to have the same computing power. In Intel, unfortunately, Intel is a CPU-based company, and they will never, ever, especially in the current state, publish some chip with neuromorphic computing. So they have the technology, but they are not developing the technology that it can be used in a real-world scenario. There are 2 other scenarios. One is from Jena. They are doing the same with optical fibers. You can add nonlinear switches in optical fiber, and then you get a neural network in a fiber. The same with memristors. So memristors have been in a buzz, I think, 10 or 15 years ago, but they never took off. But these technologies, in my opinion, are easier to develop into a full live usable version than supplying nuclear power plants. And the latest thing, which is probably the closest, use more integers, because there was a publication, the L-mul algorithm is replacing all the complicated floating point operations. You don't need them in a perceptron by integer operations. And this could save 95% of the energy. 95% is a lot if you want to deliver something on a limited energy budget. So, not to say that it is, I'm not against AI, I always have to say this, because we have seen real progress in large language models, and the only large language model which is really useful at the moment is AlphaFold, this protein folding model, and they won a Nobel Prize for this year, so this is definitely something we want to have. And this means we have to sort out what are the useful applications in AI. Do we really need create code with AI? Who will maintain this code? So CodePilot, we have seen in a talk yesterday, only 5% of a developer's work are coding. And 95% are reading code and meetings. So can you say, hey, AI, just refactor my code that it is simpler? No, I can't. Or can you create a programming language with AI that simply says it is secure, it's memory safe, and it is fast, and can use LMAL as an algorithm for computing AI in the background? No, we don't have this. We have simply only things which produce existing content like a stochastic parrot, and then it comes out that you need more expertise to judge if this is right than to write it on your own. So this will create a lot of unmaintainable code. So Google is very proud at the moment that they can really produce 25% of their code with AI, but I am afraid they will not be able to maintain it. If you cannot refactor code by AI, then more or less most of the task is left to humans. And the most scary thing is the actual development. So this is a picture from OpenAI. This is the increase of the computing power used for computing AI models. You see, from the 60s to 2012, it was more or less obeying Moore's law, so doubling every 2 years. And then the start of the AI models have increased the doubling speed so that every 3.4 months. So the computing power need is doubled. This means we need for the equivalent of AlphaGo 0, we need 67 megawatt hours. So effectively, if this would proceed until now, this is an explosion. So an exponential increase in this way cannot be sustainable. 3.4 months for doubling means in 2 years you have 2 to the 6, so this is a factor of 64 in the increase of computing demand. You have to balance this somehow. If Moore's law would apply, then you get a factor of 2, but then you have a factor of 64 for the increase. So this is more or less an explosion. And explosions will be normally terminated if one resource is finished. And we see exponential growth by explosive. Nuclear chain reactions are very popular. We see it in population growth and infections. If at the beginning of an epidemic you have this SEER model, but it is always limited by resources. And now let's look what are the limiting resources. So we have here, I have a lot of links. And the limiting resources are the energy, of course. I've already talked about this, but also the transmission grid, the water in your cooling systems, and the metal, because you have to build data centers based on real materials, so concrete and copper. Actually, nobody has on the radar that until 2030, we only have 80% of the demand for copper in our copper mining. Copper is extremely hard to mine nowadays. It's 4 times harder than 50 years ago. So you have to move a lot of rocks around just to get the same amount of copper as before. So this will also limit the way we can build new things on that. And we don't need copper only for data centers, we need copper practically everywhere. And yeah, another thing, what's on Microsoft is training in AI to help get nuclear reactors approved. Yes, we use a training input of 3 reactors and effectively have nothing against Google, but they trained cooking recipes on a satirical website, and then the outcome was spaghetti gasoline. So, and then my comment was, okay, now we have AI for cooking recipes in the high-risk area of the Cyber Resilience Act. So, yeah, I did not expect that. And the same with nuclear reactors. It's absolutely unrealistic if you don't have built 1,000 of them just to train AI on that and then, yeah, give me the new design for the next reactor. What also already happened, one of the first ones got out of business. There are lots of things. Yeah, 3 Mile Island. This is effectively not something what is going to be real. I talked to some members of the European and the German Parliament, so Green Party, obviously. And at the end of the discussion, what the nuclear power industry does is they scam the scammers. Because effectively AI is based on venture capital fantasies. Everybody believes in California that all these things can work, and then, yeah, they have done the same thing. Yes, we can build nuclear reactors in an agile way, like software. Okay, this is not real thing, but there are some people who believe that, obviously. And they are in charge in the higher management, so if you have a chance to talk to your managers when they believe that, just tell them that this is not a real option. Here are some other numbers. And most of the things I see in AI is this fear of missing out, so the FOMO, yes, if we don't get this now, then we are left behind. Yeah. This is not something which is where I would base a decision on. Another thing which came out this week, so I've been very busy adapting my old slides. We see a lot of waste because these NVIDIA graphic cards and other things in the data center have a life cycle of 3 to 5 and in supercomputing 8 years. And this means in a few years from now, you have a 1,000-fold increase in computer waste. So all these wonderful NVIDIA graphic cards will be waste in 5 years. And a 1,000-fold increase is nothing we can handle at the moment. Absolutely nothing. So, and as we see, the usual suspects, US and China are using the most, but this is not something I would compare because effectively in Europe we're also using American data centers. This is a Nature article, E-waste challenges of generative artificial intelligence. So, it's Halloween, and I want to scare you a little bit. Because the obvious answer, and I don't know how to sell it to you, is degrowth. Just use the time and look if you can degrow certain parts of the data center. Because this explosion, and it does not matter which boundary is hit first, will kill us, our economy, the energy grids, business, environment, or the entire planet, whatever comes first. All these limits are nearly exhausted. And there is a book on this, so this is from Kohei Saito, a Japanese researcher. He has written the Degrowth Manifesto, and he's also talking about all the recycling hype, so recycling of resources. It never took off. And this is a good argument why we should try to avoid unnecessary applications in data centers. And I want to scare you a little bit more. It's Halloween. And Kohei Saito is really doing his job very well. So he has studied in Berlin, and there is a group of people researching every part of whatever Karl Marx and Engels have written down somewhere, and it's a huge job, but effectively it came out Karl Marx was agreeing at its end, yeah, okay. But believe me, nobody wants a communist party. We have no working class. You are definitely not the working class. Revolutions are only successful after a war, if we look back. But what we can learn from this externalization is real. We externalize our problems to other regions, mainly the waste to Africa, the mining to Chile, Rio Tinto, or in the US, the mining also to the First Natives. The concentration of power is real, so which he has described. But what we also can learn is we can collaborate. So we have at least certain opportunities to make it better, and then we can collaborate. And the big companies are already cooperating in open source, and Wikimedia has shown that it works. So we can cooperate on making the footprint of data centers smaller without having to make a communistic revolution. I've given this example, so non-GPU AIs, memristors, optical fibers, L-mold, and saving everything. So the conclusion, this is a quote from Marvin Minsky in Life magazine 1970. And from 3 to 8 years, we will have a machine with the general intelligence of an average human being. Yes, 1970 is a little bit back. I've been in school at that time, so this did not work. In my opinion, the resource consumption at the moment is out of control, and we don't have data. So if you are running a data center, please try to give the exact data. So at the moment, the cloud companies are treating the data as secret, because yeah, then we will know the data as a summary, because effectively you have to attach it to a power grid, and then we can measure the power consumption. But what we would like to have is more fine-grained data on the real consumption of resources. So your internal consumption, the power, and the network, and the storage, and so on. This is a completely black box at the moment. I think AI at the moment, it can be useful. We had yesterday a talk about this in the same direction, but it is oversold. So it's a bubble at the moment. You see this in this diagram, you see the stock market bubbles compared NVIDIA and Cisco. So this is, Cisco was part of the internet bubble, and you see how the stock has went to the roof until 2000, and then the bubble bursted. And we will see the same with NVIDIA and the AI economy. At the moment, NVIDIA is 11% of the GDP of the US. So if you, NVIDIA plus Google plus Apple plus Amazon plus Meta, probably 30% of the US economy. If there is a bubble which will burst, then we will have a big recession and probably a financial crisis. It would be better to have a soft landing, but I'm not very optimistic on that. I believe that the money, and there are already warnings from Gartner and Bloomberg that AI is oversold and that the bubble will burst, so the money will be the first limitation, probably. Yeah, the rest is, if this does not happen, it is possible because the companies are really big and lobbying, this will harm the planet on every possible scale. There are lots of charlatanry, some outmen, massive financial interest, and we will see and are already seeing public protests against new data centers. This is not in our interest, that the public does not accept any more data centers. So this is more or less what I wanted to tell you. If you have questions, remarks, please put it into the Slack now. And if you want to contact me, the latest version of the slides is available with this QR code on my website. There are minor changes. If you want to contact me, please contact me per mail, on Mastodon, or if you must, on LinkedIn. Thank you very much.